What up, everybody? Welcome to Coffee Hour. My name is Paul Abernathy. Thanks for joining me here on a Wednesday as we talk National Electrical Code, all things electrical. Again, I live vicariously through you folks. Again, I appreciate all the emails and the stuff that we get from all of you, letting us know your success, what you've achieved, what you're trying to do in business. And if I can be of any help in any way in your success, please, by all means, reach out and let me know. I'm more than happy to help wherever I can help. I will do a slight apology this morning. Again, everything looks the same because EV Mux did not want to cooperate this morning. In fact, we're not streaming on LinkedIn because it locked out and blocked out LinkedIn. So it's not without its issues. Okay. So it is what it is. We are looking at changing a lot of things here. So I'll talk about that today, some big changes that are coming, but it's not going to be easy. It's going to be a tough change that we're getting ready to make to all of our platform. And again, I have a meeting today. So we will finish on time today. I have another meeting today about the infrastructure change that we're doing here. We're meeting with a host who supposedly is y'all heard me talk about over the weekend in some of my brief posts that we got a new server. We started that process of getting things changed and found out they had limitations even after the massive investment. So we were able to reverse that. There's problems. There's problems everywhere. I can't fix them. So that's the problem we're having, folks. So that's the one big issue that we've got right now is things aren't working, and that's a problem, right? So is what it is. I can't fix it. So yep, tube's not working, everything's not working, and so it is what it is. So follow us where you can follow us till we can get it resolved. Again, we're also looking at leaving EV Mux and ditching that platform, going back to the old platform that we used to use. So again, all kinds of things going on here that's not working. So let me go on and drop that because that's not working either. So I'll terminate the Fast Tracks tube. Again, so probably going to be a brief show today then, because again, there's just so much messed up going on, and we're going to have to uh, infrastructure. Y'all know our server was down. We had sales plummeted over the online because of the servers not being able to process, and we don't take orders over the phone. So again, it's just been a mess. So it's the last week has been horrible. So anyway, thanks for joining me again. Always in the platforms that you can watch on. If it's still working, go on and put it down. I'll make sure that we reshare this show afterwards on so that you can actually watch it again if you're like watching on one of the platforms. Try to get it up. So today we're going to talk a little bit about 2026 NEC. Some of the changes, just kind of a brief. We're not going to go too in depth in this morning show, but we're going to talk about it. It's kind of give you a kind of an overview. For those that say we're not in the 2026 yet, I get it. This is just an overview of what's to come. It's obviously not going to be all inclusive. We will do that in future episodes as we get further into it. But definitely want to do that. For all of you that came out to see me this weekend at NEC, it's great meeting all you folks. Glad to catch up with you. Had some CMECPs in the house that joined us in Chicago. So again, it was awesome to see it. So again, it was a great weekend. But again, it was long, and I loathe traveling anymore. That type. So anyway, in the comments, let me know who you are, where you're from, and we'll get into today's topic after I do some quick shout outs here. What's up, Tim? Hello, good morning. Glad to have you here. Frank, welcome. Glad to have you here, my friend. Thanks for joining us. What do we got here? Paul. Thank you, Paul. Glad to have you here. I am back in the seat. What's up? Uh-oh. Okay, that was good. There we go. David's in the house. David, good morning. Glad to have you here. Christopher's throwing up the hashtag win. Again, the drawing's here in a couple weeks. Let's see here. Adam's in the house. Good morning, Adam. Glad to have you here. Welcome. Also, guys, you can go on and bring your questions if you have questions you want to ask. Somebody on TikTok asked about available fault current. So if you have a question, you're on TikTok, you want to come over to the live stream. I think we are streaming on our Facebook accounts, Master the NEC. I believe we're on both of our YouTube channels, both Coffee Hour with Paul and Master the NEC. We are not streaming, obviously, it's not working for the Fast Tracks Tubes, not working this morning. So again, it tells me that EV Mux is having an issue, and I will let them know. Also, we are working on the new show look, and that is not utilizing EV Mux. So that is more of a problem because we have to use what's called an ingest, and we have to load it into EV Mux, and that's what's complicating stuff. We're not doing it yet. That's not what's causing this issue, but it is going to be a problem. So we got to solve that, figure it out. What is up, David? Glad to have you here. Manny, thanks for joining us. Manny did follow us from over on TikTok on here. Also, as I told y'all, we will be doing, we have been really lax on videos in the last 6 to 8 months. I put out new videos. They go over, we do the morning shows. They go over to Fast Tracks Tube. But as far as new content, so I'm going to explain that, what's going to happen with that too. So we'll check that as well. So what's up, Peter? Good morning. Glad to have you here. Red Dog.
Woo, 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 woo. Big dog.
We'll be dropping you an email. We did change email formats again, folks, because of an email server issue. So, I mean, all kinds of issues we've been having. So what's up, Crypto? Glad to have you here. Jimmy, I see you in there for the win. Angel, thanks for joining us. Let's see here. Melting Toast, good morning. Glad to have you here. Join the show. Rob, good morning. Glad to have you here, my friend. Brandon, I see you in the house. Angel, good morning. I am doing good, my friend. I cannot complain. Plus, what's the old saying? If you did complain, who the hell's listening, right? Nobody's listening. All right. So this weekend I was in NEC. It was a great show. a lot of people, a lot of new products, people coming out. It's always trying to create new things. I always encourage you, if you can get a chance to go to one of those shows, go to it. It's expensive. I think Bill, was one of our CMACPs, was there, and it was $150 just to walk the floor. So I encourage you to grab as many goodies as you can. But if you're there to get some education, they do good CEU classes as well, that type of thing. Okay. And with that said, let's talk a little bit about now. Our thermal imaging class is available on our website. You can go get it now, still being worked on, but you can go pre-get it. And of course, you can pick up one of this thermal imaging. We have very limited supply of these. Okay, very limited supply. Probably what I feel for electricians. For electricians, this is probably the best thermal camera out there for electricians. It doesn't go overboard. It's very affordable. This is nice to have. Get you a little case for it, or it comes in a box with a foam, so you can keep it in that. But this is really good to pull out on every job site and give a quick look, just to be another set of eyes, especially if you're doing industrial or commercial. It's a must-have. Anyway, what our course is available. But let me talk about courses. So our meeting today is we're going to be talking with a host that is going to be able to supply the backbone we need to create two things in the future for everything. Is one, we want to build a community. You've heard me talk about it. I don't know if that's going to be successful or not. You electricians are not real gabby. You love TikToks, you love YouTubes, you love all this stuff. I just don't know how engaging y'all are going to be in your own electrical community. So it might be an experiment that just bombs, and I've had my share of them. Okay, but I still have to at least try to see if I can't build a community where people want to come and post images and post things. And so I'm going to try. And if it works, it works. If it doesn't, it doesn't. I'm willing to invest in it and see what happens. We will be changing our educational structure. So when it comes to the courses and how they're done, so that means that everybody that's in our fast track programs, you're gonna still have the program. But we are going to come out with it's slowly going to roll out a new delivery platform, new course layout, new everything. All of you have been asking, if I'm a current member of Fast Tracks, will I get access to the new platform? The answer is yes, but it's a one-on-one conversion. So what happened is, in your module, when we do this, don't be emailing me and shit. When we do this, there'll be a module in there that'll say what you need to do to get set up on the new system. Both systems will be running together. But if you want to, and so the reason we're doing it this way is because we have people that never go back into their course. Well, I don't want to migrate everybody. You'll still have your course that's still there, but we're going to have a new layout, new system, new delivery. So it's a large undertaking. But I want to remind everybody, you will get access. You just have to follow some steps. They say, oh my God, more hoops to follow. Welcome to electrical, okay? Welcome to the electrical world, right? It is what it is. I'm sure we'll get some complaints. I'm sure some people are whining. And you know what I'll say about all that. I don't care. Okay, so it is what it is. We're not, I can't make it simple for everybody. All right. No, anyway, that's a meeting I have today. Oh, by the way, shout out Mike. We had a great dinner. Me and Mike Holt and his team, we all had dinner the other night. It was great. Mike is a great host as always, and a great guy. And we had a nice dinner and chat, talked about all kinds of things, Code. You can imagine sitting in a room with me and Mike, everybody, just talking back and forth, talking shop. So it was great. I enjoyed that. Yeah, it's a really, really good weekend. Got a lot of stuff done in 2 steps forward, 1 step back, for example, or 1 step forward, maybe it's more like 1 step forward, 2 step when it came to the servers. We're still invested in it, but it was a pain. It's still a pain. So everything's working on our site now. So for those that are interested in courses, they are on our site. And don't worry, it's going to be months before our new system rolls out, and it's still got to be designed. It's everything that we did or that Jeff did over the weekend was totally lost because the host said that they could do what they could do, and they couldn't. So this is very labor intensive move because the plans that we have, normal servers can't run what we need to run. All right. So it's more of a university level type servers. I can't explain the complexity, but our normal one couldn't do it. The people that we went to dropped like 20 grand in a reserve for the server. Didn't work. Okay. So yeah, and can't talk shop all day like you want to. Yeah. So all right. So let's kind of get into today. What we're going to talk about today is, just some thoughts. And so today it's really the National Electrical Code. Obviously, y'all all know this. It updates every 3 years. Now, some cycles are small changes, right? Good morning, John. Welcome to the show. And then, of course, there's some cycles that are bigger changes, and it's not just changing code. It's changing structure. It's the start of what we call a remapping. Now, one of the things that me and Mike talked about this weekend was a possible. It may happen if the stars align. Okay. We may have a replay, Francis, after we're done. The stars align, and me and Mike might do some type of show that is explaining the importance or the significance of a remapping or redesigning or restructure flow of the National Electrical Code from the 2023 to the 2026, and how that's going to structurally change to the 2029 to get people prepared. Already started now with some of the changes that are in 2026. It's preparing you for those structural changes, and so we're going to talk about a few of those today. We'll say today's show will end on us knowing a bit more about these changes or about these moves, so that you can be prepared. Now, it's really also for something for inspectors to watch out for, because at the end of the day, don't start quoting things until you really understand how the structure is going to change. What's up, Alberto? Glad to have you here. What's up, Charlie? So that's what we're going to be talking about today a little bit, and a reorganization. So I guess the first thing that I should talk about, and you know what? We could probably go to look at something, but before I get started, let's kind of do an overview of kind of what we're talking about. One of the big overview changes that we have that y'all saw it is that now the load calculations in the 2026 for those, when you get there, and I get it. If I had $1 for every email and text I get that people say, Paul, I'm watching your show, you're talking about the 2026, my state won't be on it in 3 years. Let me get this through a lot of you's heads that are watching this, whether you're live or. I don't give a damn what state you're on and what local amendments you have. Never have given it another thought. Okay. I teach the NEC. So for all those people that watch my videos out there and say, well, that's not what my state says. I don't give a darn what your state says or adopts. I teach the NEC. That's your responsibility to learn what your state changes it or modifies it or whatever. That's your responsibility. It is not mine. Never will be mine. Okay. I don't teach courses that are state specific. I teach the National Electrical Code. Let's just get that off. Let's just get that out of the way. Because if I had an email for every email for that, it's different. Okay. All right. Okay. Now, so everybody knows that Article 220 was a calculation. It was kind of nestled in Chapter 2. People didn't know how it structurally applied because it's a Part 1 general, and you got your Part 2 for branch circuits. Then you got Part 3. Chicago was great. I'm not a big fan of Chicago. I never left the hotel except for when me and Mike Holt went to eat dinner at a restaurant. But other than that, it was great. That type of thing. But I heard there was riots, or not riots, but protesting and all. I never saw any of it. I never left the hotel, was connected to the conference center, and I went every day back and forth. I don't go places. I don't go out and see things. That part of my travel I ended that years ago. I don't really care to see the sights anymore. I don't know. It makes me a boring guy. All right. So Article 220 was nestled into Chapter 2. Obviously, you have all heard by now, part of the restructuring is that got moved over into Chapter 1. Okay, so why did it do it? Now, it's making it very clear that the calculations are in Chapter 1, so it's front-loading it, right? So yeah. So me, it's I was very light too. I always travel very light, guys. I only take clothes for the show or for what I'm traveling for. And I learned years ago in traveling that I can get, for example, 2 days out of a pair of pants. Just have a separate shirt for each day. Dude, NEMA is what helped me back in the day. Learn when I worked for NEMA, traveling how to travel light, and I travel light. I take just what I need to get by, that type of thing. So I don't go out. I don't have three and four sets of clothing. I have just what I need. In this case, I had enough because it was only 3 days, so I had everything fresh. But back in the day when I would travel for 5 and 6 days, I still wanted to travel light. Okay, because no, Paul don't travel first class. So until you get an upgrade or until you get in status on the airlines, you got to remember that you're going to be getting on number 6 or 7 or whatever it is, and you might not have any room to store your luggage. So I want to make sure that I have the smallest bag or the smallest thing I can that can fit under my seat. So I learned to pack accordingly so that regardless of what I boarded the plane, regardless, then I was made sure that I never had an issue with my luggage. That was just how I did it. Okay, anyway, enough of that. All right, so formerly 220, now it's going to be 120. All your calculations moving forward are going to be loaded into the front end. Okay, so all the demand load math is going to be renumbered, that type of thing. So what that's also going to mean is all you guys out there that are in the field, all you inspectors, you're going to have to make sure that y'all have little group meetings when this comes around. And I know some of you are going to say, well, this is not going to happen for 3 or 4 years or whatever your state is. Whatever. Okay. You should be having monthly meetings anyway in order to make sure that you're all on the same page, that type of thing. Other impact is the energy management systems. Y'all heard me talk about SIA. It's in Vegas next year if I'm with the company next year. You never know. I'm getting very close to cashing it in. But if I am, hopefully I'll be there next year. That type of thing. Love to see you. So energy management's moving from 750. It's going to go over to 130. Again, front loading up. It aligns with the EMS with load calcs and all those type of things, and service calcs and the allowances for their energy management systems. And for example, in a nutshell, when I try to explain energy management to people, I try to say, energy management is taking into account reducing the loads to the most optimum level so that it manages the system so it doesn't overload it. And if it manages it efficiently, okay, what loads are on, what loads are off, that type of thing. If it manages it efficiently, then it helps reduce the size of your service. For years, we do load calculations and we didn't think much about energy management or didn't have the ability to have energy management. And so, we oversized services, we oversized applications. And it's probably not a bad thing because, you can go bigger, but it resulted in bigger conductors. I don't have such a problem with that, by the way, but it was larger conductors, larger equipment than necessary. It costs when it, maybe requiring 1,000 amp service when an 800 could have done it. Those things like that. So it's going to kind of align the energy management with the basic fundamental calculations that we have now that's going to be in 120. So it kind of moves it all instead of it being up in 750. And y'all remember chapters 1, 2, 3, and 4 are general. 5, 6, and 7 supplement and modifies chapter 1 through 7. In this realignment, it's making it very evident that energy management goes hand in hand with your typical service calculation. And everything today is involved in some type of energy management. The energy monitor systems, for example, that we have with SIA is, I had somebody ask me, I think it was Alex. Also, I met Alex, is usually in here. I met him. He's not here this morning. I believe he said he wasn't going to be able to make it this morning, but I met him at NEC show. Great guy. And by the way, spoiler alert, his name's not really Alex. It's really long. I don't know. I'm sorry, Alex. I don't know if it's Ukrainian or whatever, but it's really long. And he goes Alex. His name is Mike. So anyway, I met him there and we were talking, and about monitoring. And his question for me is, how does monitoring, like Arcia, how does monitoring save anybody money? It doesn't. It save anybody any money just to monitor it. Now, if it can monitor peak use and off peak use, right? Then it's basically still just monitoring. That's not management. It's just monitoring. So a lot of people are getting panels like the span panels and the Lebanon panels for monitoring. Even though they can remotely cut a breaker on and off, that's kind of a gimmicky because I don't have a need to turn anything off. That's a gimmick. But the monitoring doesn't really do you any good, except for it's kind of like continuous monitoring for your blood sugar, right? Continuous glucose monitor. If it changes your daily habits, and things like that, then it can save you energy. But it also allows you to have a forecasting of motors, or what motors may be running too long or using too much energy or not shutting off, or your air conditioning unit is cycling out too often. Typically, typical air conditioning should come on 2 times an hour, maybe something like that, depending. Typically, so it allows you to monitor this period and kind of have a snapshot of your equipment. That's what saves you in the long run, is being very proactive. In a commercial environment, you have so many motors that consume, and everybody's trying to squeeze out the cheapest bill they can. So energy monitors will help that scenario, but it doesn't necessarily save you money. Now, an energy management system can save you money because it actually will control the loads. And so, for example, we have a Pro model EVSE charger, right, that can sense the usage of current and can decide when it comes on and when it doesn't come on. It can look, if you have a peak rate and an off peak rate, then you can save money with the monitoring system, because then it can give you ideas of which appliances need to be running during the off peak. So maybe you don't run the clothes dryer, you wait until the off peak. Now, not every jurisdiction has on peak and off peak hour rates. Some are just a flat rate. And that's what Alex was talking about. He says, how do I sell that to somebody that's not really going to get any discount? It's a tough sell, except for the fact that you got to sell to them that it's kind of gives them a snapshot of what their appliances are using. And you can tell when something may be left on, like a sump pump or something's not working. It also allows you to monitor your water heater. How often is it coming on? So you can recommend maybe a timer, and that can keep it. You don't need to run a hot water heater all day long if you kind of know when your peak usages are, and you can put a timer in. So for me, from the electrician perspective, the monitoring is, I'm gonna be honest with you, the monitoring is for the electrical contractor to be able to sell other services, and be able to make recommendations to their systems, whether, that type of thing, whether they need a soft start, whether or not they could use a timer for their water heater, whether or not if they have peak and off peak, whether they can adjust their usage. But really where it shines is where you add some other components that work into the monitoring. Like if they have a PV system, then you can monitor, are they really getting the return on investment that they think they are? Because that's important, because some of these PV installers make these outlandish claims that aren't validated. It's hard to validate these claims, and you think that you're getting something. So kind of holds their feet to the fire, whether they'll do anything or not. But also, there's so many things that you can get with the monitoring. Now, add the management. For example, we have an EV charger that actually is smart. And say you get a service call and they have a 100-amp panel, but they gone out and they bought a Tesla. And you're like, do the calculation on a 60-amp level 2 charger. And you're like, dude, it's a 100-amp service and you want us to put a 60-amp Tesla charger? You still got a water heater involved in here. You got a range involved in here. You got air conditioning involved in here. Probably not much with a 100-amp service. Probably not a big air conditioner. But all of that together, your calculation may say, dude, you don't have the headroom on your service to be able to do this. Well, with a smart EV that interacts with a monitoring system, it can actually talk to the system. So it says, oh, wait a minute, without doing anything, at the middle of the night when you're not pulling power, or your water heater's not on, or you're not using the range, or you're not using it, it knows to all of a sudden start charging the vehicle. And then when some of those high demand loads come on, it says, oh, wait a minute, this is still only 100 amp service. I gave you all the benefits of a level 2, charging at a faster rate, but let me back off now and let your water heater do its thing. And so that's a smart EVSE, electric vehicle charger. So that's kind of that's where the management starts to come in, and it manages those loads. Okay. So anyway, the move to from 750 to 130 is just going to align the energy management for buildings and construction that have a energy management or use ASHRAE or something like that, or the energy codes allows them to align, that type of thing. Okay. The next thing that we'll talk about is there's new articles 265 and 270, right? So 265 is going to mainly deal with branch circuits, feeders, and services when it comes to over 1,000 volts AC. So it's even differentiating it more. Now, the National Electrical Code, I made a post on this. What's up, JC? What's up, Ace? Glad to have you here. What's up, Petey? Some people have asked me, they said, Paul, does the NEC define medium voltage? And I did a post a couple weeks ago to kind of stir the pot up about medium voltage. So the NEC doesn't get involved, even though it does talk about the wiring methods and things like that for medium voltage and calls that out. And that starts at 2001 up to 35,000. But in general, the NEC doesn't necessarily call out medium voltage as a core, okay? But what it does do is it goes 1,000 volts and less and over 1,000 volts. So what the NEC is bringing in is 265 is going to be bringing in the over 1,000 volts so we can have a clear differentiator when it comes to what we consider over 1,000 volts branch. And they're not going to call it medium voltage. Because industry standards typically call 1,000 over 1,000 up to 35,000. The industry likes to call that medium voltage, whereas then the NEC doesn't. So it can be confusing because people see the 1,000 and less, and they say, well, that must be low voltage. Then they see over 1,000 to 35,000 in the industry standard, and they go, well, that's medium voltage. Well, it is. But then the NEC pops up in there and says, oh, well, here's the wiring methods that we want you to use when we're over 2,000 volts up to 35,000, right? So it can get confusing to take industry standards that we're used to following, right? The industry stuff, IEEEs and things like that, and then try to intermingle it with the NEC. All the NEC is really trying to say is, as I break it down for you, is if it's 1,000 volts or less, you're going to use all of your traditional wiring methods that we've used before. When you're going to go over 1,000 volts up to 2,000, you now have rules that you're going to follow in 265 for those if you happen to have a voltage class that falls into that area that's kind of right there when it comes to the NEC. And then, of course, when you get over 2,000 volts, now you're going to have specific wiring methods and things to do. So that's how the NEC tries to break it down, but it can get confusing because industry standards will start calling things out medium voltage. For me, I think that it's important to realize that there's a reason the NEC breaks it down that way is because there's a lot of wiring methods today that are perfectly fine for under 2,000 volts that may not necessarily be considered medium voltage, okay? And so in most of the medium voltage that we deal with in the industry, this is all moot anyway, because most of that stuff that we deal with is going to be 5,000 volts and higher anyway for medium voltage. There's no return on value to have a medium voltage that would be less than 5,000. I mean, there really isn't. I mean, you're not going to get any benefit out of it, and nobody would choose that application. So I think that's important to understand the scope of how that's going to work. But the NEC doesn't call out that differentiator that we're all used to, right? Low voltage, medium voltage, high voltage, that type of thing. So, but there is industry standards that kind of align with that. Oh, and also 270 is going to be breaking out the grounding and bonding, whereas 250 is traditional grounding and bonding, and you're going to have special applications for over 1,000 volts when it comes to grounding and bonding as well. And that's so we've got a 270 that's going to be introducing that. Now, most of the stuff is probably A lot of it's going to be just a cut and paste, but there is, again, a significant move in order to try to differentiate and give you some additional rules when it comes to grounding and bonding up in 270. That type of thing. Let's see here. Let's see here. And also, just so we know the grounding and bonding rules, again, whether it's a cut and paste, you still got your 250. That's not changing. Okay. But you've got the addition of 270 for other grounding and bonding applications, again, for over 1,000 volts. Make it clear. What else? Limited energy systems. A lot of people get confused with limited energy. We have class 2, class 3, and now we have the class 4 fault managed system. Had a couple questions this weekend about fault managed. I will remind you, fault managed systems are pretty damn neat. Okay, they're safer than GFCI. They're safer than having an arc fault circuit interrupter. But they're unique. Okay, they're power over Ethernet to the next degree. Let's call it that. The amount of transmission that they can send in from packets from one point to another, from a transmitter to a receiver, it's already used. If you really want to get a brain dump right now, I encourage you to go to YouTube and search for a company called Volt Server. There's the creators of it. Of course, they're licensing it out to all kinds of people. If you're a company and you want to be progressive, and you want to really try to find your next little niche, okay, that you can get into as a contractor, as far as moving into bigger projects, which are going to be less intense as what you may do in a commercial project now, because when you deal with fault managed systems, you have a transmitter and a receiver, and then it sends packets down a cable assembly, which means that you can get a lot of use from point A to point B, and load into this transmitter, and it sends it through these conductors at these DC packets, and it gets to the other end and reconstitutes it out. Or you can use that higher voltage DC and then have it break, use it as it's without having to, it's much more efficient without having to convert or do any conversion, right? On the other end, and empower different types of things like a DC grid system, a DC lighting, things like that. Or you can have an inverter that can take care of that right there. Or you can, like I said, converter from AC to DC. But here it's much seamless. And so they're pretty neat. So go to online, go to YouTube. You get it from free time. Go look up Volt Server and just kind of watch some of their videos explaining it. And of course, you're going to see this rebranded by other brands, but it all comes from Volt Server. They're the ones that invented it. It is really neat technology, and it's very safe. Whereas class 2 and class 3 are typically power limited, right? And so you have a class 1, which has its own requirements. It's not in here. And it is basically like a normal branch circuit. Okay. But you have these limited energy class 2, class 3 that, like, you've seen it, the cats and the cat 5s, 5E, cat 6 now, all those things and other applications will fall under these different categories for limited energy. And it's going to be limited by either the supply or whatever the equipment is. It's going to limit the amount of current that it can handle and the voltage levels. So that's why it's limited energy. But it is expanding. And basically, it's consolidation, making it a little easier. 720 through 750 now is going to be that area where you have all of that consolidation when it comes to that limited energy. So a little bit better for that. It's basically going to be a one-stop shop area now for all of those types of classes. Okay. So, and it's going to also be the one place that you go that you're going to find out the difference between the separation rules, grounding, bonding, cabling requirements. All that stuff is now going to be simplified, in my opinion, more simplified throughout those specific articles when it comes to limited energy. And we'll go look at the code book here in a minute. Let's see here. Switches, device type switches, Article 406. Okay, wall switches moved here to sit with receptacles. Okay, so this is going to be device types. Article 404 remains. And the 404 is going to remain for large switchgear and large disconnects. So snap switches, wall switches are going to be kind of relocated, that type of thing. Okay. The other thing that was added, and I think it was much needed because me and Mike were talking about this. It looks like Article 625, when it came to EVs, for the last couple of years has been all over the damn place. It seems like everybody's confused. I get questions all the time about the use of the receptacles with the little marking on it, right? Hey, Bill, glad to have you here. Bill's in the house. I met Bill this weekend at NEC.
Big dog.
Met his daughter as well. Great guy. It was awesome catching up with Bill. Sure enough, he had his CMECP hat on in his pen. I was like impressed. Okay, but I think Bill probably knew he was going to see me there, so he was staging it. You know what I'm saying? I'm just saying, Bill. I'm just saying. But anyway, look sharp. It was a great, represents the CMECP program perfectly. Okay, so it was great to see you there. Okay, I'm sure that everywhere you went, people are like, dude, get out of the way. Get out the way. Get out the way. Hello. It was good to meet her as well. Very sharp young lady. All right. So new article 624 is going to make an attempt to try to make 625 a little easier to understand. Okay. So 624, which is going to be electric self-propelled vehicle power transfer systems, which means that in 625, we had the EV, electric vehicle chargers, and how they interact with the EV vehicle, and it left a lot of confusion. What happens when you have bidirectional, and for inspectors, what are the rules and how do they differ? Well, in 624 that's being introduced for EV, it's going to cover the self-propelled vehicle, how it connects to the premise. Okay, so it's going to cover charging, but it's also going to talk about the bidirectional component. Okay, the export from the vehicle into the actual structure, which is huge because we're going to be offering an EV system that is bidirectional. So it means that you have the potential for the transfer switch to actually be in the EV charger, and you plug your vehicle in it. And if your vehicle has this massive battery, then basically when you're selling somebody an EV system, they get a Tesla, that if it has the capability to bidirectional charge, like a Ford Lightning truck or something like that can offboard power, that it can power in, it can be a backup, right? That type of thing. So, yeah. So I mean, it makes it a very sellable to people because now they have an ESS that can integrate into the system. And if manufacturers create components that make this easy, like if you're already going to plug into the EV, and it's a smart EV that can act as a transfer switch, then guess what? Now you have the potential to import power or export it from the vehicle, import it into the system, and use it as a standby system, like an optional standby system. Okay. So in doing that, it's going to require listings. It's going to require the overcurrent, disconnects, grounding, and bonding on the premise side to deal with that ability to bidirectionally charge into it. Now, what's the key differences? I guess that's the biggest thing is 625 in its traditional sense is going to be more focused on the EVSE equipment. Okay. One-way flow, premise to the vehicle. That's the concept, and try to simplify this because again, I'm going to be honest with you, 625 gave us some direction moving into the 2026, but it was really a struggle for many people, especially with the advancements coming in again with transferring the bidirectional flow. So 625 is going to resolve itself to being very much about the EVSE, the charging system itself. Okay, think of it as a one-way flow. Whereas 625 is going to get into the self-propelled vehicle power transfer system. And it says, okay, it's going to cover the connection point where the vehicle ties into the premise wiring. That's important, right? And not all vehicles will be able to do this, by the way. You'll know because the vehicle will be for that. I think Teslas can do it, or it would be just a service, an upgrade to their software. It includes bidirectional flow. Okay, so that is vehicle to the home, vehicle to the grid. Okay, huge. that we had a clarification in 624 on how we would have to deal with that, because we're going to be the potential to take your EV vehicle and when it's fully charged, how can it put power back onto the grid, just like you hope that a PV system will do. One of the interesting things also I will say about some of the new chargers that are coming out with that, the ones that we will be offering, hopefully, if everything goes right. That's why you haven't heard me talk a lot about SIA, because we're still in negotiation for that. But we will still offer them. It's just, we still have to, there's still room to be negotiated. I got so much on my plate. I just hope I don't have a heart attack and die before it all gets done, because I don't know who's going to finish these deals when I'm Jeff. I don't know, so let's hope I don't kick the bucket. Although there's people out there, if you've watched the Charlie Kirk thing, there is definitely, I'm sure, people out there who wish Paul dead for some reason. This is the way it is. It's sickos in the world. But at the end of the day, we need some, we have to have systems that communicate, and we have these new EVSE systems that will bridge that gap between 625 and 624 in order to be able to bidirectionally charge and pump it back to the grid when necessary. And I also learned that the system is also being developed to be able to take the excess energy and be able, from a solar system, and divert it to charging the vehicle without sending it back to the grid. And why is that important in these new systems that are coming out? Well, because you may have a better return rate by charging your vehicle than it would be what you send back to the grid. The grid, spinning that meter in the other direction, it may be less of an impact on your savings than it would be to say, you know what, it's better to go on and charge your vehicle with that excess energy than just send it back to the grid. So if I'm generating more than I'm consuming, depending on how my storage is, then I might be able to say, what? I'm just going to kick that to the car instead of to the grid. And some of these systems now are getting so smart to do that. And we're going to have one of the first ones in the market that comes out with that. And it's going to be the Pro model. So that is interesting. And it's going to require bidirectional disconnects and overcurrent devices to understand this bidirectional aspect of it. So manufacturers that make these are going to have to catch up with that. And as we all know, the National Electrical Code does not regulate vehicles at all. So one of the big concerns was, does 624 have anything to do with the vehicle? No. Vehicles are basically designed to the SAE standards and the UL 9741s and the DOT jurisdictional requirements. NEC plays no part in that. Okay, it's just how they interact. Okay, so if you think about it this way, 625 governs the charger. 624 governs the connection between the vehicle itself, becomes part of the building's electrical system. The NEC never reaches inside the car. It only governs what happens at the premise wiring system. Okay, so 625 will cover the charger. 624 is going to cover the interaction and how we protect the conductors on both sides of that interaction. That's what it's really going to, in a nutshell. Make sense? Okay. GFCIs. So you're seeing the introduction into this high frequency. Now this one we'll go on and go to the code and let you see how we're dealing with this frequency thing. So let me go to the code really quick to see if let me see if it loads. Okay, we're in the code really quickly. I'm going to go to 210.8. Y'all can see the code book. And so this is actually, for those that have link, and I guess they info. What's up, RKT? Welcome. Somebody introduced me and let me know that the link is now available for the 2026 available. So if you do have link, that's a beautiful thing about it. You get to see early, that type of thing, right? Get an early glance at it so that you get a kind of an idea of what's going on. Let's type of thing. So let's see. Hopefully everybody can still see me or hear me. I think I got it pretty much fixed the other day. So, all right. So here you see basically still the same listed class A. That didn't change. But You see down here, we do have an informational note just reminding us that UL 943, it says for the further information, markings HF or HF plus. Okay, it says Class A GFCIs marked HF or HF plus are evaluated for use with loads having high frequency leakage currents from power conversion equipment, such as variable speed drives and inverters. It's still just a general rule. Okay, so it's just a rule in the code, but I think what the important takeaway from us is that the manufacturers understand. And I was trying to go down a little bit, and we already talked about this the other day. So I'll point this out. Okay, so make it clear. So here's really in the exception. So this is the exception right here. For example, for those outdoor outlets. Okay. You notice that it is outdoor outlets, and then it's talking about if equipment supplied by an outlet covered under the requirements of this section is replaced, the outlet shall be supplied with the GFCI protection, right? So then you have exception number 3. So this is what introduced a listed Class C SP GFCI protection. Okay, so let me clarify first. You have your normal GFCIs, okay? You have your normal Class A GFCIs. Basically, we refer to those as a 5 milliamps nominal, but they're actually under 5, 4 and less, they're not supposed to go off. 6 and greater, they're supposed to activate. So we call it 5 nominal. It allows the manufacturers to have something to shoot for. But you also have what's called this special purpose GFCI from a manufacturers who say they're available, and they're going to either have an HF or HF plus mark on it. And this is going to be a situation where you're still going to meet the GFCI requirement, but you may have these devices that are designed or they're tuned into a frequency. And that's typically where we were getting nuisance issues, is various frequencies from different motors and appliances, high-end appliances. That frequency is what was causing this nuisance trip. Okay. And so that was one of those issues where you can actually have this special purpose. And so if you're going to install these for the HVAC equipment, which require GFCI protection, then you know what? You have an exception to that. So let's read the exception again. The code comes up. It says, exception number 3 says listed Class C SP GFCI protection shall be permitted for listed HVAC equipment if a Class C SP GFCI is provided. The disconnect serving the HVAC equipment shall be marked warning Class C SPGFCI protection provided for the HVAC unit. Now you still have exception number 2 here that said GFCI protection shall not be required for listed HVAC equipment. This exception shall expire September 1st, 2026. So there's still a sunset date in there allowing, and again, for all those out there who that need to understand, this doesn't matter whether it's hardwired or cord and plug, although I don't know any outdoor HVAC equipment like this that would be cord and plug outdoors. So it's typically going to be hardwired from an outlet, all right? That you can get away with not having the GFCI protection until September 1st. But if you choose, then you can go with a Class C SPGFCI, okay? But you have to mark it as such to be able to achieve that, okay? So for whatever reasons for that. Okay. Anyway, so let's get back to me. Let's get back to me here. Okay. So that's what we got going on for that. So the HVAC again is paused. Okay. Oh, and by the way, your Class A HF or HF plus, okay, clarifies that the SPGFCI classes C, D, and E are going to have some special purpose applications. There may not be the same milliamp thresholds as we would for a normal Class A GFCI, but that's also why it requires the additional marking if you choose or elect to do that. If, for example, We're not going to let somebody say, look, it just won't work, and I'm going to just circumvent the GFCI altogether. There are options now, supposedly, from the manufacturers. We'll hold them at their word, okay? So here you go. But we are going to allow the Class A HF or HF Plus. We are going to allow that, or we're going to allow the Class C SP GFCI with additional marking requirements. Okay, it's going to be allowed. Let's see, what next? Arc flash labels. Okay, arc flash labels, working space must now include voltage, boundary, incident energy, PPE, and assessment dates on all of those arc flash labels. Working clearance, clarified clearance by equipment type and voltage. And then bring, let's see here, NEC closer. The NEC is now moving a little bit closer in alignment with NFPA 70E. Okay, so those type of things. So if we go look at the NEC, can do that. And we go look here at the NEC, and I just kind of take us back here to some 110 requirements, right? And we'll just go down here real quick and look at 110.26 down here. So you start to see some of this verbiage. You see this grayed out area, right? Right? And you see this, alignment a little bit in here, existing buildings. Some of the verbiage is just realigned. Here's limited access. All this looks like it was kind of reworded. Don't worry. In the future episodes, I got to tell you about what's coming up or what we're going to be doing to make things a little bit easier for everybody. Let's see here. I just was looking to see if there's any massive significant changes. I mean, nothing that we're not going to cover. No, so no significant. It's just making it clear the verbiage. So let me tell you an announcement. In the new platform or the new video structure that we're going to be coming out with, there's going to be a lot more shorter videos, a lot more 3 and 5 minute videos that are going to take one element of the code and break it down very cleanly, right? So that you go watch it instead of having to watch an hour. You're going to have it say on the video, it's very clearly what this video topic's covering, and we'll try to keep it brief, under 5 minutes. And that's going to be, for example, if I'm going to talk about continuous loads, and I do a video on continuous loads. This is the feedback that we got. I told you we had so much in the works. This is the feedback moving forward. We are structuring it so that the videos are going to be very concise and address the topics without trying to cover an entire article or an entire section in a video. They're going to be very specific to certain things. Like, for example, working, might talk about receptacle spacing in 210.52, right? Whether it's A, B, or C for countertops and things like that. The videos are going to be very specific and precise, right, to that topic moving forward, because that's what people want. They don't want, I know some of you do, but they don't want the 30-minute videos. They want the more concise 5 minutes and less type of video format. And so we're going to cater to that and try to make that a staple moving forward of those type of video. That does not mean we're going to share them on TikToks and other platforms because we're making them shorter. It just means that it's going to be a little easier for people to palate, especially on mobile devices and things like that. So that is something that we're going to do. So I don't know if I made that clear, but that is definitely something. All right. So let's see what else that we want to talk about. Hold on, I'm gonna lose a TikTok, guys. So that's it, guys. Does anybody got anything? We're gonna go into deep detail, and it's kind of just some overview of things that are changing. We are going to be redoing our calculation videos. Okay, some of you are excited about that. We're going to be breaking down the calculations even deeper, and then putting them together over on Fast Tracks 2 in their own category. Okay, so we'll be breaking those things down. And also, we're going to make a concerted effort to do these in a way that it covers both the 2023 and the 2026 changes, so they can be utilized now, because there's a lot of states that are just now going to the 2023. And then over the next year and a half to 2 years, there'll be more that jump to the 2026. So, and more will be leaving the 2020, and we'll be doing a lot less with the 2017. Even though I know there's pockets of it around, we'll just be doing. We have to continually press forward, so keep that in mind. Okay. All right. Has anybody got any questions on anything? I did have a gentleman that asked about available fault current. And so, available fault current, for example, here's little nuggets that Adam always talks about. We got little nuggets in here. So available fault current, if you look at 110 and 110.9 and 110.10, you'll see that available fault current is the amount of energy, the incident energy that can happen at any point on the system. So what we concern ourselves in the code is the main one is the service. So we have to post what the available fault current is. A lot of time that's given to us by the utility based on the proximity of the source, right? So we need to understand that, because we need to make sure that the equipment that we install can handle the available fault current. So they have to tell us what is the available fault current. You can calculate it yourself. As long as you have the impedance and you know what the transformer is, you know what the length of conductors are, then you can calculate this all out. I can't really start this calculation until the actual utility tells me what their available fault current is at the actual lugs, or actual termination at the source, the transformer. On residential, it's typically never going to exceed 10,000. They usually make that guarantee. So I can promise you most of the equipment downstream from the point of attachment is going to be fine. Most of the service equipment in residential is 25,000 AIC rated. And the breakers that go in line are usually 10,000 typically. And basically they're series rated. So they're taking the benefit of whatever the main is. So it doesn't matter that the breaker is only 10. Residentially, you're covered. In large commercial applications, obviously it's more impactful, because you never know what the available fault current is, and it's a cascading effect. Okay. So whatever the available fault current, we have to still make sure that the equipment is going to handle the available fault current. And we also understand the short circuit current rating of the enclosures, the buses, and everything that's associated, not just the overcurrent devices, which is the AIC rating of that. And it's marked on the breaker, right? And infuses typically have a much higher rating on it than you would for a standard molded case like circuit breaker. So we need to know those things. So the utility will provide us the starting point. They might provide it because they bring it to the actual service. They might bring it all the way to the point of attachment, and then you can calculate it. And I can promise you, if the value they give you at the point of attachment based on their source is less than what your rating is of your equipment, then I wouldn't worry about it. Because again, you only start to, because your equipment, if it's 35,000, for example, and they give you the available fault current from the utility to the service point or to the meter location, and it's only 20,000, and your equipment's rated 35,000, then you don't worry about it. You don't have to worry about it, but you still have to mark the equipment and make it relevant to the equipment, making sure that whoever's looking at it knows this, okay? Especially if they come back and they change something later. They need to know, all right? And so they have a date, and they need to know when this evaluation was done. If you're doing it in other areas of the code, I'm going to tell you right now that it's less impactful for you if you have service equipment and it is well within the scope of the AIC or the SCCR of whatever's being supplied by the utility. And then you go further down with feeders down into the system, okay? Then when you get down into it, if it's 25,000 at the source and the service equipment's rated 35,000, okay? Then you go downstream in a feeder, it's going to be less than what's at the source inherently, because the impedance of the conductors as it moves downstream, okay, is going to be less, okay? So there's certain areas in the code that are still going to require you to do a calculation on that. But look, you got to lighten up if you're doing reviews, because if it's 35,000 rating at the service equipment and the utility tells you that it's 22,000 coming in, and you start demanding a value on different things downstream, and you're like, well, I've got to know, obviously it can be calculated out. You got to know the different length of conductors. I need to know what's up here. You just simply plug it in a software like Cooper Busman has one. But I always tell the people that are reviewing this and doing it, I'm like, you need to lighten up a little bit. Okay, don't take your job so proudly. If it's 35, if the equipment's rated 35 at the source and the available fault current's 20 or 25, then if your equipment downstream is equal to whatever it was at the source, or if it's greater than the amount that was at the source that's supplied by the utility, there is absolutely no real way that there's a problem on the equipment downstream because it's not going to see the same amount of available fault current that's a source. It's not. Okay, so without getting into really complicated calculation or using the software, again, if the utility says it's 25, my service equipment's 35, okay, and I got 35 feet in there, and I've got somewhere in the code that wants me to know what's the available fault current on another piece of like switchgear downstream, and it's 100 feet into the system, and that equipment's rated 35, then, or at least equal to whatever the service is, for example, do I really need all those calculations? That type of thing. So anyway, it's just a common sense thing to me. But it is what it is. The code will tell you when you need the available fault current calculation. When you need that, you do your best to do it. That type of thing. But again, it's more of a common sense approach to it to me in that scenario. Okay. Now, where it can be critical is that you got to remember that some loads also contribute to fault current. So if the service goes out or power stops and you have motors that are going, they all of a sudden turn into generators, right? And so they can contribute it back, that type of thing. So again, like that. Yeah, David, you do plan review. I would never do that for my customers because it increases the liability to my jurisdiction. I never messed with it. I just wanted them to provide me with the numbers, and as long as that engineer stamped it, I was fine. But I never get into calculations like that because it made my jurisdiction liable. Okay. So I as long as they said it was good and I looked at it, I stayed away from trying to calculate the impedance from point A to point B because it raised liability for my jurisdiction, and our lawyers did not want us to do that. So we just verified what the equipment rating was, what the available fault current was at source, and if it's downstream, if they say that it was okay, I'm okay with it. The moment that I start calculating it, I'm playing the engineer, and I was not a PE. So, but again, we'd review it, but I had too many to review. My guys had too many to review. If they tell me that the equipment downstream is equal to or greater than, then I'm good. I was good with it. That type of thing. Too much for me. I just didn't want the liability. Something blows up and they point a finger at me. No, not me. But everybody, everybody does things differently. I get it. I'm just always was looking at liability. Many lawsuits as I've been involved with, I'm just looking at liability. All right. Anyway, what else? All right. So anyway, that's kind of the available fault current type of scenario. We can do a show one day and show the structural layout of the available fault current, and we could calculate it out using Cooper Busman's app and that type of thing. Yep. Back in the day. Oh yeah. And that's the problem. Yeah, Dave, me too. Once you get into the weeds and understand it, and you're like, now you look at it as a reviewer, I can't not look at it, right? But I had to make myself go, okay. But again, a quick shortcut, because I make them provide that. That's their responsibility, right? As a plan reviewer, they got to provide all that. If the code requires available fault current numbers and the markings, they got to provide it. But what I tried to do is not dig into the weeds. So if I looked at what their available fault current was and their equipment upstream was greater, equal to or greater than their available fault current, then I know that equipment downstream, which is typical standard industry, that equipment, if that equipment was equal to or greater than whatever the available fault current was on the front end, then I didn't even have to worry about it. Whatever they gave me, as long as it was stamped and it says it was equal, I just like, okay, fine with me. I'm not going to get into the weeds because it's physically impossible. In my mind, it's physically impossible to have a 20,000 available fault current at a service, have a service equipment rated for, let's say, 35,000 in a commercial, and then go downstream. And if I have a piece of equipment with an SCCR rating and an AIC rating on that equipment that is equal to or greater than the service source or the actual source available fault current, due to the length and impedance, it is, to me, it's impossible for that to have an available fault current downstream that would exceed that at the source. So if I saw that and I saw that type of thing, it's kind of like what? Selective coordination, right? If it's selectively coordinated in the breaker here and the one below it's exactly the same, and this one was already selectively coordinated, and this one was exactly the same, then it does not have to be selectively coordinated because it's exactly the same. You know what I'm saying? Same concept for me. And it made my job easier as a plan reviewer. Is I can look at it and go, oh well, shit. The switch gear is 35,000. Service was 35,000. Available fault current is 20,000. I was good. I didn't have any problem. You get me? You know what I'm saying? All right, let's spin the wheel. Get some people on the contest here. Let's hopefully this works. So let's see if I can't do some spinning and get some people on the drawing here in a couple weeks, 2 weeks maybe. And if you're not in the infrared course, you'll see these are available on our website. They are cheaper than the MSRP on our website. This thing right here, let me tell you what, buddy. We have another model that we're getting that is a plugs into your phone, but I don't think it's better than this thing. I'm gonna be honest with you. This little one here is perfect. I am very pleased with this model and the detail in this thing, and the ruggedness of this thing. So check them out. We have only a few left on our website. If you want to pick yours up, pick it up. But we're going to be doing some videos with that as well. But the course is available. It just doesn't have graphics yet, but it will have. Slowly we'll be adding them in. Remember, when you buy our courses now, they don't expire. So don't worry, it'll keep evolving. But at least you get a head start into it before the all the images are added. And then once that's all added, the price could go up. I don't know. But you can check that out now if you're interested in it. Let's see. Ace West. Let's see. Dallas. All right. You're in the drawing, my friend, for an Ohms wheel coin. If you're not familiar with what those are, we make these coins and we put them, whether you're a master or journeyman, that'll your choice. And it's basically has an Ohms wheel on one side and it'll say on the other side, master electrician or a journeyman electrician, whatever you want. It's a nice little novelty. A lot of people buy these to give to apprentices who become journeymen or journeymen that come masters. So we have companies that buy these and they present it to them as a coin. It's kind of comes in its own little case. But that however somebody does that, but that's what they do it for. So you're in the drawing for that, Ace. You didn't win it. You're in the drawing for it. Okay. I have a big difference because people send me emails going, hey, I won something on your show. No, you're in the drawing. You haven't won yet. Good luck to you, my friend. Nashville, what's up, Greg? I think Nika's coming to Nashville 2 years from now. I think, no, it might be Memphis. Carlos Martinez. You're in the drawing for the flashcards. Now, those are great cards to get you prepared to learn the articles in NEC. And we will have one coming out for the 2026. Why? Because what better time to start learning all of these changes than to go through the 2026 flashcards. So those will be coming out soon, and they'll get you for those that want to get prepared, because some of the states that will be going, for those that are testing, by the way, you're not going to see pretty much, maybe Massachusetts change to the 2026, probably first of the year, maybe. They adopt it right out the gate. Texas, it's not going to change probably to 2026 until you get more towards closer to September, October of next year. So you got plenty of time. You shouldn't need that long to prepare for an exam. 90 days is what we recommend. Study 2 times a day, 4 hours each session, or you can study 3 times a day for 2 hours each session, whatever you want to do. But you need to put at least 90 days in. If you don't have 90, 60 days, study 3 times a week for 4 hours each session. And just have to have a mindset that I'm not doing anything else. I'm going to devote my time and I'm not going to get distracted. for that period of time, because getting a license is life-changing. Whether you know it or not, getting your license is life-changing. So you need to devote that amount of attention to it. Everything else gets put on the back burner for that short amount of time in your life. Once it's done, it's done. They can't take it away from you. Adam, did you pick up one? Awesome. I should let people know that the course is different than this. So this is a separate purchase. So you still have to get the course. For those out there who wonder, this is sold separately. The course doesn't come with this, by the way. I just make sure I'm clarified. That's just, we sell the thermal imager, but you can use your own if you have one, that type of thing. So they're different. Course is different than the thermal imager. Hopefully I made that clear. It should be. One's in the shop and one's not, that type of thing. Let's see here. What else do we got? Oh, let's spin a wheel again. Let's go. Good time to pick these up. And if you're in contracting anyway, and you want to start adding the service to your normal service calls, I have case studies in our program. We have case studies where people have found stuff on service calls that were eminently going bad. Because you look at a breaker, you can't really tell. And even if you use these, which is just a laser, you can't see what's going on behind the breaker. Okay. So that's the deal. I use these to help calibrate this. Not really necessary. This is accurate. But you really can't see what's going on behind equipment. You really need the thermal to really see what's going on. Type thing. All right. What do we got? Leo Reyes, you are in the drawing for the Slate coasters. So those that don't know, we have Slate coasters on our website. There you go. Slate, bunch of different designs. You can check those out. All right, let's spin the wheel again. I mean, a lot of people have been buying. We are starting to sell out of these. We only have a few left. But I have tons of people that are buying these because they already know how to do thermal imaging, but they wanted to Christopher. So you might already be familiar with thermal imaging, and so you just want to get a thermal imager. So check it out. We have very limited ones there. Okay, so not a whole lot of them still left. All right, folks, we will see you next Wednesday. We will have a specific topic, and hopefully some of this will change, and we have the new system. We're going to have a heart-to-heart talk with EV Mux, who's our support, who actually does this streaming. We're going to have a heart-to-heart talk with them, and if we have to change, I will make the change before next week because I don't like to pussyfoot around, okay? I'm just saying. We like to get things done. So till next time, folks, stay safe. God bless. We'll catch you on an upcoming episode, Coffee Hour. We probably will replay this afternoon at probably 5 o'clock. Take care. God bless. We'll see you next week.